All right, we are going to just work through a couple of problems that you might see on your homework just after school, and we're going to get cracking here. So everybody should have a 7.1/7.2 just kind of a worksheet, and like I said, we're just going to work through a couple of these, give you a couple more examples before you get cracking on your homework. All right, so we're going to start off 7.1 and 1, and let me change the color of my pen. And let's see here. Let's go orange today. All right, for each distribution below, identify each underlined number as a parameter. So I'm looking for parameters, or is it a statistic? And then make sure you use the correct notation. All right, so I got to be correct notation here. 1993 survey conducted at the Richmond Times-Dispatch 1 week before Election Day asked voters which candidate for the state's Attorney General they would vote for. It's probably going to be going on all the time. 37% of the respondents said they would vote for the Democratic candidate. So here it is, 37. That is of the respondents. So that is a sample. Okay. And so I'm going to say this is going to be p hat 0.37. And that is a statistic. I don't know if I have to put that or not. That's a stat. Okay? And then on election day, 41% actually did vote. So the actual percentage is 0.41, and that is a parameter. Sorry, I know it's really bad writing, but you'll live. You'll live. No one's dying because of my writing. All right. Any questions there? Good. All right. Moving on to question B. National Health Statistics reports that the mean system blood pressure for males is 128, and the standard deviation. The medical director of a large company looks at medical records of 32 executives in the age group, finds the mean blood pressure for these executives to be this. Well, this right here is just for those 72 people, right? So I'm going to say the mean is 128. That is the true bit right here, see? That is the true 128. And then it says that's a parameter. Okay. And then I'm going to use X bar. Okay, because on that 126.07, because that is just our sample. The sample of the 72. So, and that's called a statistic. Alright, now I'm going to go freehand for a little bit using my mouse, because as soon as you see that blue bar, I can't write anything more on my iPad. So here we go. Question number 2. Let's pick something really good here. Let's go purple. Okay, suppose two different statistics. Call them statistic A. Alright, and then statistic B can be used to estimate the same population parameters. Statistic A has a lower bias, so it's lower bias, so that means it's probably going to be centered better, but has a high variability rate. Okay, so that means it's not going to be necessarily centered, but high variability means it's going to be wide. So statistic A has a lower bias, so that means it's going to be more centered, but wider. On the two axes below, draw the two parallel, the blah blah showing 8 values. I don't know what this 8 value stuff is. I'm just going to avoid it. We're going to draw two normal curves that would meet this variability. So statistic A has lower bias. So a low bias means that it would be centered more about the average. Okay? But it has a high variability, so that means it's going to really range far. Okay, it means we did not collect very many samples. Okay. Statistic B then must have a bias. So now it's up to you or me. Where do we want to make this bias? Let's make the hill over here. Okay. Uh-oh, somebody's knocking. I'm going to make the hill over here, and I'm not going to make it as wide because it says some stuff. I'm going to pause this for a second. All right, sorry, I just had to deal with the student. Whoa, that I have no idea where we left off. Anyways, statistic B is not centered at the right spot because it says it has it's got to have a higher bias. And so it's not going to be centered, but it is going to be lower variability, so it's not going to be spread out as far, so it's going to be more condensed. So that's 1 and 2, just kind of talking through what we got to do. All right, moving on. Number 3. Large pet store. Specializes in tropical fish, several thousand guppies. The store claims that the guppies have a mean length of 5, so they say the center is at 5 with a standard deviation of 0.5. You come to the store and buy 10 select guppies and find that the mean length for your 10 guppies is that. That's what I found. Ooh, that is my X bar. 4.8. All right. Makes you suspect that the mean fish length is not what the store says. Let's be a little detectives here. Are they lying to us? So, it's not what the store says it is. To explore this further, you assume that the length of the guppies is normally distributed, and use a computer to simulate 20 samples of 10 guppies from a store's claimed population. Below is the dot plot of the means for these 200 samples. Alright, so this is what my simulation has gathered. I'm assuming it's roughly normal. What is the population in this situation, and what population parameters have we been given? Alright, so the population would be all guppies all guppies at a large pet store all guppies length. How do I put that? All guppies at a large pet store's length. Period. Okay? And what have we been given? Well, we have been given, the population parameter we've been given has been 5 centimeters. Okay? And we also have been given a standard deviation of 0.5. Okay? Alright, next, going freestyle. Distribution of one sample is described in the opening paragraph. What information have we been given about the sample? Well, we have been given, I already wrote it out, alright, that our mean of our sample is, I think I wrote it above, 4.8. I barely turned that one around. Wow, that actually didn't turn out too bad. Alright, and I think that's it. There's no standard deviation or any of that kind of stuff. Our sample that we got was 4.8. Is the dot plot above a sampling distribution? So, is this a sampling distribution? Well, this represents 200 samples, or 200 simulations. But remember, the sampling distribution would be all of the ways possible. And this is only 200 different ways. Okay, it could happen. And I'm pretty sure there's more than 200. So, we're going to say, is this dot plot above a sampling distribution? We're going to say no. Okay. Now, it's a good start of a sampling distribution. I'm going to say no, comma, you know what, I'm going to start typing it out. Here we go. No, because not all simulations are represented. Period. There we go. Alright, only 200 of them are represented there. A sampling distribution will have all of them represented. Okay? And barely ever do we actually have a full, because it would just take forever to plot that many dots. Do you think the store is being honest about the length of its guppies? Justify your answer. All right, we're almost done. Well, we got a sample. Let's be detectives here. We got a sample of 4.8. So this right here is where we got 4.8, right?
At this time, all students are asked to exit the building unless they are being directly supervised by
Gotta love Joyce.
If you are waiting for a ride,
What a gal.
do so at the front
What a
of the
gal.
building in between the doors. Thank you.
All right. So here's my deal. I'm pretty low on the totem pole. If this is a true simulation of a lot of events, I'm right down here. How many people did I beat out? Let's count it. I beat out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I beat out 17 out of 200. Now, I'm no genius, but I think that's about 0.085. Ugh, those 8s are killers to write with your mouse. All right, it's about 0.85%. Now, do you think they're being honest? 0.085. Well, this is kind of up in the air because I'm down there really low. The probability is very low. However, I do have this thing that I usually like to say in statistics, and that is, hey, listen, if it's not lower than 5%, I just don't have enough evidence. All right? And so 8%, although it's very low, comma, I don't feel like I have enough evidence to make a big stink about this at the store. So I'm not going to go romping around in there, even though I only had an 8% chance of getting what I got. I just don't, I'm not going to go in there and just like raise hell and knock over a bunch of fish tanks and say, you cheated me on my lengths of fish. If it was less than 5, though, I definitely would. You know, I'd take a zapper and just kill every last fish in there. But that's just me. All right, get going on your homework, and we'll have another video a little bit later.